this is the walkthrough. Basically what I wanted to do was take the opportunity to walk you through the anatomy of a good project based on everything that we've learned, everything I've learned from talking to employers and talking to mentees who've been hired successfully. This is sort of like the breakdown of what we've learned works really well. I want to make sure if you have questions along the way, as always, like feel free to ask away, because I think there's going to be some actionable stuff here too with respect to your particular projects. Oh, there we go. So do feel free to ask away. In any case, I've laid out a high-level summary here of what a complete project looks like, but I'm going to dive into each individual component separately. The first piece, of course, is to come up with your project idea. And this component is the one that I think it's fair to say most people do really, really wrong. They treat life like a Kaggle competition. They will look for a data set that's publicly available. They'll just try to hack some metric that they can optimize, and that's the extent of their analysis, the extent of their thought process in terms of project ideation. We'll get into what goes into good project ideation, but the upshot is you want to make sure you're building something that's of clear value to someone, because you want to engage in that thought process, that business thought process, where you're asking yourself, how can I build value with this data? How can I build value with this project? So that's sort of the first piece. We'll talk about collecting your own data. We'll also talk about cleaning and exploring it. I think all these things, the way that you approach these things changes quite a bit when you have the mindset of building something with genuine value rather than just building kind of a project for the sake of building a project. And so cleaning rather and exploring your data really does fall into that bucket of things that you'll do very differently if you're thinking of your project as a product, as something where you're trying to build value for people. So we'll explore that a little bit. And then this piece, okay, so training and optimization of models, by the way, this is really something that most people over-index on. Most people do, I would say, almost too much model fine-tuning, too much model optimization, and so on. And what exactly it means to do too much model optimization we'll get into, but it's definitely possible to do. And there are a couple of techniques that we'll talk about that will help you kind of figure out, am I doing too much? Am I going too far overboard with this hyperparameter optimization stuff? Because that can get pathological. Model evaluation, also really important, something that people should spend much more time on than they typically do. And again, we'll see why. I mean, there's a deep connection here to the idea of building something that's of genuine value. The evaluation step is absolutely critical, and then showing off your work to the world. I just want to talk a little bit about promotion of your projects, what kind of format to put them in, and so on. Because again, I mean, this is like when you are building something of value, you then need to deliver that value somehow. And this is the step where you really think about what it is that you're going to be putting together at the end of the day. Before you even start your project, you really should give some thought to each of these steps. And just like in a notebook or something, not a Jupyter notebook, but just like a physical notebook or wherever you want to write, write out what you think would go into each of those steps ahead of time. Try to do a little look ahead, because especially with this last step, like, you want to know how you're going to be showing off your project at the end of the day. And if you like, this is a really great way to avoid regrets, where you might build out your whole project a certain way and then realize, oh shoot, this makes it really hard for people to use, or this isn't really the thing that that's easiest to show off. So you want to actually go through this these sort of 5 steps beforehand, or 6 steps beforehand. Okay, so I want to start with the very beginning, step 0, coming up with your project idea. The first thing, and I think this is something people really screw up because school teaches us not to do things this way. What school teaches you to do is to basically overfit to some curriculum that some professor imagines will be useful in the real world, and to then trick your professor into thinking that you actually know more than you really do. That's sort of, in a nutshell, what the interaction is about. It's about deceit. You're trying to lie to your prof to pretend that you know everything in the textbook, which you don't, and then the prof is trying to figure out if you're lying to them or how you're lying to them by giving you a test that's designed to adversarially prod your knowledge and to reveal the fact that you're actually an ignoramus, when in reality you're presenting yourself as genius. That's academic education in a nutshell. This is a really bad paradigm to approach projects with. Your project is not you trying to show that you know so much. Your project is you trying to show that you know how to build things that create genuine value. And so you want to, as closely as possible, map the value that you're going to be showing off in your project to the kind of value you need to create in the jobs that you're applying for. And so, sorry, I think I hear a little bit of clanking. Gaurav, I might just mute you if that's okay. I think I can hear cutlery. Just feel free to unmute yourself if you have questions. Just no worries. All right, thanks. Great. So yeah, so you want to map your project to your kind of dream jobs, and the way you do this is by going to a job board, Indeed or Monster.com, wherever. Type in data science or machine learning engineering, whatever it is that you're targeting, and then take a look at the jobs that come up. And I think a lot of you guys have heard this spiel from me before, but I want to make sure that I repeat it here. You identify the say 5 or 6 job postings that you're most interested in, and look at the list of technical requirements. That list of technical requirements, especially if you order it from most common to least common across those 5 job postings, that becomes your technical spec. And as long as you're learning those tricks, tools, and techniques, you're focusing on the right thing. You're focusing on the exact skills that you need to succeed in the workplace because companies are telling you that's what they want. So this is the difference between like academic education, which is an overfit model to whatever is between a professor's ears, and getting ready for actual jobs, which involves you being proactive and figuring out what should my curriculum be. The way to do that is to find what companies are actually asking for. So job boards are a great proxy for that. It's not 100%, but it really does narrow things down quite nicely. So that would be step 1. Come up with your project spec by mapping your project onto the kinds of jobs that you're targeting. Make your project useful and unique. So remember that when a recruiter is going through your resume, when hiring managers look at your resume, they're parsing a ton of these things, and a lot of the people that whose resumes they'll be looking at are going to feature a lot of similar projects. And you might roll your eyes at this and say, "Well, I know. I mean, I'm not going to use the Titanic data set. I'm not going to use MNIST. I'm not going to use like these obvious iris data set, like cookie cutter type data sets." But in reality, like almost any kind of Kaggle data set and almost any kind of open access data set is going to fall under this heading. I've seen a lot of resumes, and they typically do involve the same Kaggle competition will come up many, many times, even if it's not like a headliner Kaggle competition that everyone has heard of. It does have a way of sort of showing up. So Miguel, I'm just going to mute you. Sorry about this, just for the background noise, but feel free to unmute yourself if you have questions down the line. There we go. Sweet. Okay, so yeah, so uniqueness is really important just because it creates that FOMO. People don't tend to have FOMO with respect to people who seem like they're a dime a dozen just because there's so many similar projects out there. So as much as possible, I would stay the hell away from Kaggle. Kaggle is good for refining your skills, your modeling skills specifically, but it has a lot of limitations, and we'll talk about a lot of these more in detail when we talk about the next step, which is collecting your own data. But the long and the short of it is you want to stay away from Kaggle and collect your own data yourself because you want to ensure uniqueness and usefulness too. I mean, one of the things here is you want to be driven by your passion and your interest in a given area. You want to be driven by your instincts to build something that's of genuine value. So when you go out and, again, we'll talk about this in the data collection stage, one strategy you can use is to go out and find a list of public-facing APIs. So open access APIs, I'll share with you guys a link to one that I like, that I included actually in the SharpestMinds mentee documentation now. But essentially this is just like it's segmented by industry, and you can go to finance or healthcare or ed tech, whatever you're interested in, and check out APIs that you can hook into. So that's really useful, and it allows you to focus on things that you feel like you'd need. So you can actually be inspired by, hey, like I'd love to have a tool that did this for me, and that allows you then to build something that's more useful, just by giving you that extra kind of freedom to collect your own data, to define a data set that will allow you to build value in the way that you want. This next step, I think, is one of the most common mistakes, and it's probably the headliner thing coming out of this this slide, and that's constraining your resources. So most people approach data science problems, especially when they build their own projects, by being very open-ended. So because your mentality is like, I want to learn, this project is my excuse to learn, that has a way of expanding the time horizon untenably. So you can end up building your project for like weeks and weeks and months, and pretty soon you're creating this giant Frankenstein monster that gives diminishing returns. And while there are some exceptions, like when you're doing research level deep learning or something like that, almost always you want to time constrain your projects. And the reason is that this helps you mimic what you're going to have to do in real companies. Like your boss is going to care if you're able to produce a project on a given time horizon. They're going to come to you and say, hey, we need you to make this thing, and I want X, Y, or Z like on my desk on Monday, so to speak. So the very first thing you do, and this is before you start coding anything, you need to decide what your time horizon is. So I'm going to build something in 6 weeks. I'm going to build something in 2 weeks, in 12 weeks, whatever it is, and you can talk to your mentor about this, or you can just decide it for yourself. You want to have that constraint. What that constraint does in practice is it forces you to make exactly the kinds of trade-offs that you will have to make in the workplace. And that's going to give you, it'll empower you with stories you can tell the hiring managers about those trade-offs and how you navigated them. So when you tell them, for example, like, hey, I really wanted to do this project on e-scooters because I'm very passionate about them, but I told myself I've got to get onto the job application process, or I've got to get onto something else. So I'm going to give myself 3 weeks to do this, and because of that, I wasn't able to explore complicated models. I just set up a baseline logistic regression, or I did a simple tree-based model or something like that. That's really where you start to sound a lot more like a professional data scientist. And that de-risks the hire for hiring managers. In that they will hear someone who has their priorities straight. Your priority is to deliver. Your priority is not to engage in some open-ended quest of self-discovery as you peruse different Python libraries in search of the perfect algorithm. So this really is, that constraint piece is so important. Constrain your time, constrain your money, and constrain your compute. So you don't have unlimited resources to spend on cloud compute, so maybe a deep neural network is not always the ideal solution. In fact, it rarely is. So simple is often better, and it's often better for exactly this reason. Companies have these limitations, and they want to be able to hear you talk the talk. And by the talk, I mean that process of basically rationing of your resources and your time to ensure that you're focused where you need to be focused. And that really ties into these next 2 points, actually. Define your metrics and your win condition. Okay, so what do I mean by that? Well, if you're designing a movie recommender system and you're hitting 99% top 10 recall or something like that. In other words, meaning that the movie the best movies that the person that you're recommending to wants to watch is going to be in the top 10 99% of the time. That's really, really good. Is it really worth taking another 2 weeks to get from 99 to 99.5? Right? Well, in that case, probably not. Now, that's really important because it ties into this idea of constraining your resources, constraining your time in particular, right? If you don't have that win condition ahead of time, you can easily find yourself spinning your wheels because yes, you can always do better. You can always do better. But you can only come up with that win condition if you actually have thought about what value you want to create with your project. If on day one you're like, I want to make a product that recommends movies to people. As soon as you say that, you have implicitly specified a win condition. Because we all know how good a movie, roughly, that is, how good a movie recommender has to be before we say, okay, that's good enough. Whereas on the flip side, if you're talking about making a predictive model for Goldman Sachs that's going to have them trade securities or something, and every fractional decimal point of whatever the metric is worth hundreds of millions of dollars, then yeah, probably go further, right? Probably push that harder. So the kind of task that you specify determines your win condition, and it also determines the metric that you care about. Because you have to have a very specific use case in mind before you can have a metric that even makes sense. The classic example is don't come up with accuracy as a metric to assess the performance of a coronavirus test, right? I mean, if 99% of people don't have coronavirus and you're using accuracy as a metric, a model that predicts that no one has coronavirus will be 99% accurate. So the use case defines the metrics, and it also defines the win condition. And the reason it's so important to go through this thought process is when you're in an interview with a hiring manager, this is what they want to find out about when they're talking to you about how did you decide to do this project? What was your thought process? They're probing at this kind of thing. Are you able to trade off your time intelligently? Are you able to operate with constraints? Are you able to define win conditions? And then once you hit that win condition, by the way, even if you're 2 days into your project, you're done. Why would you keep optimizing something to a point where there's diminishing returns if you've already met that win condition? So that's actually a really important piece of this too, and it's part of why you have to do this on day one before you even dive into the project. Because you want to have that, like, that ability to say, okay, I thought about this when I was sober and calm, and I decided that this was the right place to stop. Whereas if you just dive in, you'll always be telling yourself, well, I could get more out of it, I should push harder, and so on, and you'll start to blame yourself if you don't live up to that standard. So how good is good enough? I mean, this is the question you need to be able to tackle, and that depends on your use case, your application. I'm going to pause there because I'm sure a lot of you guys are working on projects and stuff like that. Does anybody have questions about this first stage, the ideation piece? You don't have to, but Edward, it's good to see you again. How are things? Actually, hey, do you have any? Oh, no worries. Okay, I'll leave you go. But yeah, no worries. Let me know if you have any questions about it. But if not, I'll leave you be. Okay, sounds good. All right. Maybe I won't prod anyone else for now, but if you have questions, feel free to fire away, folks. Okay, good. Step one, which really is, I mean, step two, but step zero was, I emphasize, by the way, with step zero because I really think it is the first thing you should be doing, and it has nothing to do with code, right? This is all business, no technical stuff here. So you just want to tick that box and even make notes for yourself or something like that, and commit before you dive in, so you don't move the goalposts. Cool. Collect your own data. I think someone. Oh no, sorry, that's just a Hangouts glitch. All right, collect your own data. We talked about this idea of using APIs to collect your data. I really like this personally because APIs are most of what you'll be doing working in a company. You'll be like putting in requests for data from different databases, paying different services, and so getting comfortable using APIs is a really good kind of software engineering box to tick. So I do recommend doing that. I'm providing a link here to, I'll click on it just so you guys can see what it looks like. This is a public-facing API list from GitHub, and basically, yeah. So here we go. So you can see how it's indexed by like all these different topics: animals, anime, anti-malware, art and design. I'm not going to read them all because there are a lot here, but you can basically go through and see, like, in each category there are a ton of APIs. Like, look at this Smithsonian Design Museum. How cool is that? You can check all this stuff out. And just kind of get inspired. I mean, just a lot of stuff here that you can chew on. So definitely recommend checking that out. Really worth doing. So yeah, there's APIs. There's web scraping, obviously. If the information you want is on some website, you go check out whatever website that is and like scrape the HTML, and then so you can use tools like Beautiful Soup and Scrapey for this. There are a ton of others, of course, but something to look into. And one cool idea for getting a unique data set, I talked to some mentees who've done this, and this is a little bit rarer, but if you can do it, it makes for a really great story, is to put in access to information requests or email companies or people, get in touch with them and do that gritty legwork, that investigative journalism almost of saying, like, hey, I'm just building a project. I'm wondering if your nonprofit has a list of whatever, or a data set that looks like this, because you tend to work with people who do X, Y, or Z that might be related, and so on. This is a really good way of showing grit, showing determination, and showing as well that, like, you're really, like, where information hides in the world. And just again, a really great way to tell stories about what you're doing, because when you're interviewing with a company, that's what it's about. It's about telling a story around your project. Your project intrinsically has relatively little value. Your project has value to the extent that it's a sales trick that helps you get in the door with companies, so you lead with it in your reach out emails, and it's a conversation piece when you're talking to people because you don't have experience. It's your closest proxy, so you really want to mimic what a production flow, what a professional workflow looks like with your project. So you might sometimes have to put in these access to information requests. You don't have to, by the way. You definitely don't have to. If you're using APIs or web scraping, like good on you. That's fantastic. But this is just, I don't know, something I wanted to flag because I thought it was really cool. And then, yeah, keep track of the challenges you run into. This is important because of storytelling. the last thing you want to do, and this, in a way, it's kind of like when you write your resume and you realize all the stuff that you've done. And you're like, oh man, like I'm actually, I'm kind of accomplished. I've done more things than I thought. And that's the exercise of sitting down and actually consolidating that and like thinking about it. It's really hard to do if you're like reflecting on 5 years ago. But if you keep your resume updated as you go, you'll notice you're much more likely to remember stuff on the way. And so this is the same sort of principle. As you struggle with accessing the data, you're going to run into like problems where APIs will crash, or a website is designed to fight against web scraping and make it hard to scrape, and you'll overcome those difficulties, or again, these access to information requests, this and that. It's just really good to keep track of these challenges because they will come up when you're doing your interviews. And the thing you want to do is position yourself as that person who has the grit to get data wherever it's hiding. And that's a really comforting thing for a hiring manager to hear. Even if they know, like day to day, you're probably going to be set. Most of the data is going to be available. Every once in a while, they're going to want you to pull a rabbit out of your hat. And these 3 strategies really speak to that. And keeping track of the challenges you run into as you execute these strategies, really important for that too. Just going to quickly pause there, actually, if there are any questions about that piece. Okay. All right. Cool. Clean and explore your data. Sorry, someone's getting in there. As I mentioned before, really keep your objectives in mind, keep your win condition, and keep your metrics in mind, and what you're building in mind as you clean and explore your data. I think the biggest mistake people make when they do data exploration is to forget, like, it's like you almost slip into like academic mode. You slip into like school mode where you're like, oh, I have to complete this assignment. And like, what does data exploration mean? Well, it means whatever it takes to convince the prof that I know what I'm doing. And that's how most people approach it. But data exploration is not some cookie cutter process. If you think of your project as a thing where you're trying to build a specific, like there's a specific end goal that you're trying to accomplish, all of a sudden, like it makes sense to invest more time in some areas and less time in others when it comes to data exploration. Another thing that I didn't mention here, though, is you also do want to put a cap on your time for data exploration. Again, any open-ended process, you want to commit ahead of time to limiting the amount of time you're going to spend on data exploration. It could be 3 days, it could be a week, it could be more. But you want to limit that time so that you don't just spin out of control and just keep digging and digging and digging. At a certain point, you got to cut your losses. So keep your objectives in mind, and don't fall into the trap of like, I'm making I'm making a PZA plot because that's what my prof did in a lecture or whatever. Just focus on what you're trying to accomplish and ask yourself, man, like what plot would be helpful to look at in order to solve this problem, in order to build this value? And you might be surprised at new kinds of visualizations that you never even thought of might become relevant and helpful, and really worth exploring. So definitely, like those objectives, you should be keeping them in mind everywhere, but especially on open-ended tasks like data exploration, like you definitely want to do that. Right, so really explore, you want to redefine what exploring data means to be anything that gives you high-level insights. That, by the way, can include modeling. So you'll notice what I'm doing here is I'm trying to change this definition of data exploration from like do the regular data exploration things that profs tell people to do in universities to do what's useful. Do what's useful to give you an idea of what's going on with that data set. And like when I say this can include modeling, by the way, I would say, if you build a basic decision tree to analyze your, to make some dummy prediction on your data set, well, if you inspect that decision tree and you look at the branch points and how that tree is formed, you're getting an idea of which features are most important. And that, I would argue, is data exploration. I don't think that's actually any kind of predictive modeling, really. There's a continuum between the two, but that qualifies as data exploration. And depending on your project, things like clustering could count as data exploration, things like dimensionality reduction, but it all depends on what your end goal is. So anyway, keep those objectives in mind. You really want to do that. Here is the very kind of greedy, crass way of putting the keep your objectives in mind bit. How can I make money off this data? What could go wrong as I try to do that? Being guided by like, would I pay to use this? Would someone pay to use this? Even if you're imagining a fictional customer and they probably don't exist, it's it's okay as long as you can weave some kind of narrative around this. One of the, I think, deepest truths about not just data science, but any kind of job is that you really are sort of a startup of one. You're going to have to build more value than you consume in salary one way or another when you go work at a company. And that means you have to get really good at doing the startup-y thing of figuring out what people want and making that thing. Now, those people could be coworkers. They don't have to be real customers or consumers. But at the end of the day, you're going to have to create that value. And so thinking about, like, where does the money actually come from at the end of this project? Maybe I'm just a cog in a big machine, and that machine is what makes money, and I'm just making it run more efficiently or whatever it is. But there's got to be money in, money out, and you have to work out, like, how does my project enter into that? How can I argue somehow for the value of that project? So really, really keeping those objectives in mind and keeping the value generation piece in mind. Again, money is a crass way to put it, but it really has a way of focusing the mind. Like, and it'll cause you to scrap a lot of project ideas right on the runway, because you'll realize, like, hey, there's no real case to be made here. Any questions about that piece, the data exploration or anything? Okay, all right. We'll hit up number 3, train and optimize your models. This is my big pet peeve. Everybody does this. Everybody does this. Everybody and their grandmother trains and optimizes their model. Everybody and their grandmother does a ton of hyperparameter optimization as well. The problem is that you can actually overdo it, and very, very often, and this is a real noob mistake, people lean into hyperparameter tuning as if that's the problem with their project. Like, when they find that their model isn't performing well enough, most people go, oh, it must be a problem with the model. So they'll go and just go ham on hyperparameter optimization. Oh, I got to try a grid search that's super exhaustive, and then somehow that'll solve the problem. Sometimes changing your model is the right thing to do. Sometimes optimizing the hyperparameters is the right thing to do, but your hyperparameter tuning is not going to buy you a world of improvement, except in very, very rare cases. Typically, if you throw I think I've said this before in another office hour, but if you throw a totally unoptimized random forest at a problem, like, you're going to get the 80-20 result that you need. Like, it's very rare that you won't. This is pretty typical of many models, maybe less so the simpler ones like logistic regression, but or support vector machines. But in a lot of cases, hyperparameter tuning is not it's not your slam dunk. It's not your golden gun. So don't spend too long here, because everyone else will. I mean, this speaks to this differentiation idea that I was talking about earlier. You want to seem unique, and these hiring managers are fielding Jupyter notebooks that are chock full of random search CV, grid search CV nonsense that is just a time waster. And people aren't even usually what they'll do is they'll do this super exhaustive search where they're not even like going through the list of hyperparameters and wondering, like, which ones are kind of redundant. Now, usually there are quite a few redundant hyperparameters. You don't need to tune them all. And this is a great exercise to actually understand your models better. I mean, the hyperparameter tuning piece is where you understand what the different parts of the model are and how they affect your predictions. So take a look, try to triage and pick not too many, maybe 3, maybe 4 hyperparameters to tune, and then let it go. You don't want to overinvest in the stage. Somebody asks. Jeremy says, I'm curious to hear about why you think grid search is a waste of time in model development. Oh, okay. I need to walk that back. So I definitely don't mean to say it's a complete waste of time. You should do it. It's not going to revolutionize your model most of the time. So if you're getting 80% accuracy out of the box, don't expect to hit 95 just because you did some grid search CV. Grid search is a little risky because it's not constrained. So what a grid search does, and I assume most people here are familiar with it. I'll just kind of nutshell it quickly. So take a decision tree, for example. So decision trees have a whole bunch of different hyperparameters. It's like a game of 20 questions that you play with your data set. One hyperparameter might be like, how many questions do you let the tree ask, right? And another might be how many final prediction buckets. That's what you end up with at the end of the day, is a bunch of buckets where your predictions land after they pass through the tree. How many prediction buckets or leaf nodes is your tree going to have? And so what you do is you say, okay, well, I don't know a priori, I don't know ahead of time what the ideal tree depth is or what the ideal number of buckets is. So I just have to do trial and error and try a whole bunch of different ones together. And so you might say, I want to try every depth, every max depth from 5 to 20, and every number of leaf nodes from 3 to 10, right? So now you've got a grid, basically, all the leaf node values on the x-axis, say, and then all the number of questions on the y-axis, and then you're testing every combination permutation of those. And the size of the hyperparameter space you have to scan just grows explosively, especially when you start to add other hyperparameters on top of that. And you start to add like a z-axis and then a fourth dimension and so on. Very quickly, it just takes a huge amount of time for your computer to chunk through, to crunch through all those numbers and then assess which model performs best. And at no point have you externally specified or thought about your own personal cap on the amount of different combinations that you're willing to wait for the computer to try. Random search CV is, in this regard, much better. So what random search does, it says, okay, define a grid, just like grid search. So I want to test every value from here to here and every value from here to here and all the combinations, except you're going to randomly select different combinations of those features and try a limited number of those random combinations. That limited number is something you specify. And I'm a really big fan of this because it forces you to think about your constraints. How long does it take to test like one combination of parameters? You can find that out pretty quickly just by doing a test run, and then you can say, okay, well, how much time do I have to do this? I'm willing to wait half an hour maybe while my computer does this. And if that's the case, that implies a certain number of different iterations. And you can plug that in if you're doing random search. If you're doing grid search, not so much. You're doing an exhaustive search of your hyperparameter space, and it has this way of psychologically fooling people into thinking that exhaustive is better. And there are mathematical reasons, including overfitting, why that's a really bad call, or why it can be, and you can overdo it. But just from a business standpoint, from a business value standpoint, I'm a big fan of anything that causes people to think more in terms of how much time do I have to solve this problem, and that's going to be the constraint that I impose on this piece of the data science lifecycle. I hope that answers your question, Jeremy, but feel free to chime in if you have a follow-up. So yeah, one of the notes on this too is like simple is better, usually. Again, I'm leaving out you deep learning cats out there because I know there are quite a few, and that's totally cool. In some cases, you have to use deep learning. But in many cases, in fact, in most cases where people just go ham and use really complex models, think about going simpler. Simpler models tend to be more interpretable, so it's easier to catch when there's a mistake. One of the problems with data science, of course, is that like your code can compile perfectly, but be completely wrong, right? Like your computer won't always throw an error when there's a mistake somewhere. And so in model interpretability, using simple models like logistic regression or decision trees, I would even argue interpretable models like random forests or tree ensembles are good for this too. It can really help. So think about, this is going to cause a lot of you a lot of anguish and pain, because I think people tend to feel like imposters. The main reason people feel like imposters is that they don't know the fancy models. And they go, oh, what if somebody asks me about a fancy model? And that may happen, but that's textbook knowledge. You can literally invest time just understanding fancy models, and that's totally cool. But when it comes to solving a real-world problem, which is 90% of what people will care about in practice, in interviews, you want to understand simple models deeply rather than sophisticated models shallowly. So think about those trade-offs. Think about the time constraint and the value of simplicity. I think is going to become apparent. Interpret your model. This is what we're talking about. Take a look at, build a basic decision tree. Take a look at how it's making its decisions. Take a look at what kinds of samples tend to get bucketed where. I would argue, this is either the modeling side of data exploration or the data exploration side of modeling, but there's a lot of overlap between those ideas. And to reiterate again, I think in like a fourth way here, but model selection is important, but it's not as important as you think. So it's not the case that you can just whip out any old model and like a support vector machine will work just as well as like XGBoost or whatever. But the idea that you're going to spend, a lot of people do this where they'll say, okay, I'm going to throw like 6 different models or 12 different models at this, and I'll do hyperparameter tuning for each one, and I'll pick the best one. Very often what's going on there is, number one, you're spinning your wheels, but if your performance isn't good after you've tried like 2 or 3 models that seem to make sense for the data set that you have, chances are your problem is feature engineering, feature selection, your data set might be dirty, you might need more data. Those are much more likely hypotheses than you just need to hold out for like AdaBoost is going to solve your problem. Once you get to the bottom of the bag and you start to reach for GBMs or whatever it is. Sorry, this isn't a rip on those models. I'm just sort of like, it's an example of a very specific kind of model that it might take you a while to get to. So try simple models first, bias in favor of simplicity, and assume that the problem is with your data rather than your model if it doesn't work out. And that's where data exploration is useful, right? Part of the goal of data exploration is so that when you get to the point where you're training and optimizing your model, you already have an idea of how challenging or how solvable your machine learning problem is. Like if you do a bunch of visualizations and clustering and you're like, oh damn, like I've got really clean clusters and like my class A is way over here, my class B is there. Okay, that's a good hint that you have a solvable data science problem. And as a result, it's worth assuming that you can invest in modeling more so. But if you're doing your data exploration and you see no trends whatsoever, like maybe you have shit data. Like that's always a possibility. So keep that in mind. It always could be the case. Any questions about any of this stuff so far? Okay. All right. Right on. Cool. Evaluate your model. Okay. This is where we're going to do a bit of a loop back. Remember, you defined a metric at the very beginning. What step? This step. Come up with your project idea. You came up with a metric here. In fact, it was right here. Define your metrics. Define your win condition. Okay. So when you're evaluating your model, you need to care about what your metric is and what your win condition is. Doesn't mean that's the only metric you use to look at your model's performance. You might iterate. You might realize, like, hey, actually, it turns out that precision is really important for this, or recall is really important, or whatever metric. But you definitely want to bring back that metric that you thought about when you were calm and sober on day one, and you want to use that metric as the focal point of this stage. You want to tick that box for sure, and ask yourself, like, hey, how does that stack up versus my win condition? Right? When I set out to do this project and build this recommender system or whatever it is, I decided how good was. How good does good have to be? And if you cross that finish line, like unless you learn something new over the course of your project, and always be open to that, but unless you learn something significant that causes you to shift what your win condition is and to make that shift consciously, you cross that finish line, you're done. The reason that's so important, by the way, is when you're working in a business, like if you can finish a 2-week project in a day, then that's 2 weeks that you can spend working on another project. Like that, you can build value in other ways. And companies want to make sure that you're not just like, a hamster spinning in your wheel, just chipping away because you've been assigned this task. Again, that's that academic mindset, that university mindset. Well, I've got 2 weeks to do this, so I'm going to take 2 weeks. That's a vanity metric. It's a very bad criterion. Once you hit your win condition, you have won. And declare victory and move on. That's really important. You might not have hit your win condition by the time you hit your evaluation stage, and you might need to do more. Doing more can mean a lot of different things, but again, most typically it means going back over your over your data set and asking yourself, do you need more data? And is your data not clean enough? Like those annoying fundamental pieces are much more likely to be the thing you need to fix than the fun project building, model building piece. Oh, there are always exceptions, but you really need to make sure that you're keeping that in mind. A lot of people get into this loop where they'll go, okay, like evaluate your model, and they'll go, crap, like I haven't met my win condition. So then they'll go back to step 3, and they'll say, I need to train and optimize my model, and pick a new model and optimize that. And then they'll get into this loop, and they'll do it again, and it still won't work. And then the worst part of this is when that starts to happen, it's an easy way to convince yourself that you're like a bad data scientist because you're like, oh no, I'm somehow using these models wrong. Well, most often it's that you have a garbage data set and you either need more data or you need cleaner data or both. And this is really something that that's a very dangerous step. You want to go all the way back and say, look, now when knowing what I know now, am I close to my win condition? So is it a matter of just nudging things forward just a little bit? In which case, hey, maybe hyperparameter optimization will get you there. But more likely than not, go all the way back and see if you can engineer more features. That's another quick win. Anything that'll cause your model to work better. But the key thing is, do you need to do more? It really is possible that you have an unsolvable problem. And that doesn't mean you failed. And this is what I think one of the most important parts of this process to really grasp. It's possible that your data is just garbage and that it's impossible to get more data. I would argue that if it turns out your data is garbage, it's a great opportunity to shine and to develop your story of struggle with your project and to show that you have the grit to find more data. But it's possible that even with that, you're not going to get there. And in that case, you're going to have to go to your data exploration. And if in your data exploration, you see signs that oh, actually, you know what, there really is a pattern here. I should be able to solve this problem. That's a hint that, yeah, okay, don't give up so easily. But if your data exploration is just a complete catastrophe and all you see there is a bunch of noise, then hey, yeah, maybe this isn't a solvable problem. I can tell you actually, SharpestMinds, I did a data exploration and predictive modeling project at our end for just basically to match mentors and mentees together, and it turned out at the time that we did not have the data we needed in my first attempt, and no amount of digging was going to surface more data. And so we just had to make the decision to say, okay, look, it turns out the conclusion of this project is that this is not a solvable problem. And that's a valid conclusion, but just make sure you're in a position to defend it because you don't want it to seem like that's just how you deal with adversity. Cool. So the final piece here is how can you measure or estimate the value you created? Can you do it somehow? I'm a big fan of tying concrete metrics that tie back to business success. So even if, for example, you're building something that's not actually going to be sold to anyone, see if you can map it on to something concrete, like how many people per day would save X amount of time, or how much time per day could somebody save using your thing. And if their time is worth, let's say, minimum wage or something, use that as a lower bound. Then how much money essentially are you saving people with this app, tool, or service? And this is just something to keep in mind. I mean, you really should be thinking about how you can make the case for your salary. And that's really what you're doing, right? With this project, you're building a case for your salary. Every feature that you build, every struggle that you overcome really is you saying look, I could be doing this professionally. And if I pulled this off, then maybe I create $500,000 of value for you next year and I only cost you $100K. We've got a good deal going here. So that's anyway, a bit of background. That by the way, the evaluation step, this is people who spend more time on step 4 evaluation and on step 2 and 1 rather than step 3. That's a sign of data science maturity for sure. And it's a really, really positive indicator to hiring managers, to mentors as well. So just on signaling alone, it's going to do you some favors to show that you're focused on the right things, on building value, really, which at the end of the day is what it's all about. Cool. So here's the last piece, and that's showing off your work to the world. This is something that people get shy about. They don't tend to dive in as much as they could or should. There are a lot of different ways that you can share your project with the world. The first one is deployment, and this is, I would argue, basically it's a must-do unless you're aiming for data analyst roles, and even then, make a Tableau dashboard, make some kind of dashboard. You should be deploying. Deployment, if you're building a modeling project, it means doing something like Flask Heroku. So using Flask, in this case, to build a web app, and Heroku to deploy that web app so that people can go to a website and actually play with it. This is useful for sales purposes. In addition, obviously, it teaches you how to deploy, and don't get me wrong, that's important. But just the deployment step itself is a crucial part of your sales process. Because when you're reaching out to companies, you're going to send them an email or a LinkedIn message, something like that. Definitely don't go through a job board. When you do that, your message is going to include a link to your project. And if that project is just some Jupyter notebook sitting on GitHub, that's extremely boring for people, right? These hiring managers have lives, they have families, they're busy with quarantine stuff. So when you send them like 300, 400 lines of your code to review as like your first date conversation topic, that's not a good way to hook in with them. So you really want to make sure that you're sharing a toy with them. And that's really what this deployment step is about. You deploy your model, you have a bunch of nice little fields where they can enter all their personal data or whatever your model needs to do to perform, and then they can play with it and see what the outputs are compared to different inputs. So really important. This we found actually does correlate with response rates quite strongly. So really recommend doing this. That does not mean that you don't also have a GitHub. So you also want to include that link to your GitHub from your app. So once you have it deployed using Flask, Heroku, or whatever, include a link back to your GitHub. So if the person is interested in seeing that Jupyter notebook, they can. But fundamentally, you want to design this as a funnel. It's a sales process that you're running. And if you hit them with the GitHub first, that is a great way to get them to turn around. It's like being on a first date and then revealing all of your inner anxieties to the person right then and there. It doesn't go very well. So you want to start off by presenting the best possible version of yourself, which is deployment, and then only later do you let them know that you're a compulsive gambler or a psycho. That's the GitHub step. You eventually have to do that, right? Like they're going to want to see your GitHub before they actually engage. But anyway, that's the idea. Deployment and GitHub, these are definitely, GitHub everybody does. So this falls under the category of like, hey, like if this is all you have, you're really not very exceptional. Deployment is different. That is unusual and great way to stand out. Blog posts, a lot of people do this. Still really useful because a lot of people also don't. So write out a blog post. This will help you to organize your thoughts too. Because when you're in storytelling mode, when you're doing those interviews, people who write blog posts, you'll find that you're basically just relating your blog post back to them. Once you've already organized your thoughts, it kind of gives you this unfair advantage in storytelling where you know exactly what order to talk about your challenges in, so it all kind of makes sense. And so taking a week or so, even at the end of your project, to do this blog post writing, really, really high leverage activity, and you're not going to realize it until it's too late, until you're in a job interview and you find yourself babbling. And Arthur says, oh, geez, sorry, you guys have a bunch of, okay, I'm sorry about this, guys. Okay, let me get caught up here. So when do you know you need to give up with bad data? Yeah, this is a great question. Okay, and the top thing I'm going to say is you won't know because it's impossible. Like no data scientist has ever been 100% confident that their data is the problem, but they've been like 99.999% confident that their data is the problem. So embrace that uncertainty to some degree. This is going to come down to a judgment call. One of the best ways to know if your data is the problem is data exploration. So for example, a really good starting point is just to make like a scatter matrix even. Suppose you're doing like a regression problem or something. A scatter matrix is like a scatter plot where you plot every variable against every other variable. And Pandas has a function called scatter matrix. That's sort of why I'm putting it that way. That gives you a great holistic sense, a great sort of high-level picture of what your data set looks like. And from there you can see, are there obvious correlations between different features and the thing that you're trying to predict? And you can run down the line and really kind of explore and get a general sense of like, okay, does there seem to be helpful information contained in like variable one and feature one when it comes to making those predictions? And the way you get reasonably confident that you have a bad data set is when you make plots like that and you really can't see any kind of pattern. And if that's the case, chances are good that modulo the possibility of a funny interaction between different features that then might give rise to something with predictive power, you're probably dealing with just a garbage data set. And that's okay, like, that can happen. Another way to determine whether your data set's just dirty is try doing PCA on the continuous variables at least, and see if there's natural clustering that you see. And if it looks like different classes are clustered apart from each other, that's a pretty good hint. Or you can use TSNE for the same thing. Basically, they're two different dimensionality reduction techniques. But if your dimensionality reduction doesn't show clear separation between classes or a clear gradient with respect to a regression parameter or whatever, probably a good indication that you've got a non-ideal data set. Arthur, good question. Yeah, how do you sell your project? As a project you did with SharpestMinds or an academic project? Well, if you can get a client, wonderful. But in general, you won't, and that's okay. I recommend being absolutely honest and straightforward with folks when it comes to the selling part of the project. What did you do? So just think about this for a second. If you go to a hiring manager, you tell them like, hey, I wanted to build this project, but I'm aware that in the real world, I won't have unlimited weeks to build it. That sounds like arguably even better than, hey, I went to build a project for this client and they only gave me 3 weeks. What you're showing there is that you're actually self-aware enough to realize, like, no, there are external constraints, and I wanted to make sure I built something that taught me the skills I need to succeed, and I recognize time constraints as being part of that set of skills. So being very upfront and saying, this is a personal project that I built out of a passion for topic X. So being passion-driven is like a really good idea when you're trying to do project ideation. By the way, that's why in the project ideation step, collect your own data step, I linked to this GitHub public APIs repo because there's so many options there. You're going to find something that you're passionate about, be it sports or fashion or entertainment. There's going to be stuff there. So really building a project you're passionate about, lead with a passion and let them know, yeah, I artificially imposed these constraints because I want to make sure that what I'm building teaches me the skills that are relevant here. I feel, yeah. Absolutely. GitHub can have projects that were just copied, he's saying. So this is so deeply true. If you go to the average person's GitHub repo, it's just an absolute nightmare. It's a mess. You look at it and you're like, well, half the stuff is forked from someone else. Maybe you made contributions to it on top of that, but I can hardly tell when I just look at this complete mess of a repo. Sometimes there's like a dozen folders. Some of the stuff is from your Coursera project or your Udacity MOOC or whatever it is. So clear out your GitHub. Like be a GitHub minimalist and recognize that a hiring manager has 10 seconds of time that they're going to give to your GitHub. The last thing you want is to have them have analysis paralysis and just see all these different folders and go, I don't even know what I'm supposed to look at. Give them one clear project, that your headliner project, one repo. I know a lot of people get anxious when I say that because they're like, oh man, but don't I need to show that I've been doing a ton of stuff? You can add one or two other things, but I actually, like, one project is plenty, because as long as that project is fully fleshed out and it includes a deployment step and it includes data exploration and all the story of your, you should have a README with a bit of a story there, that's much more valuable because it gives them a single place to focus their attention to evaluate you as an end-to-end data scientist, data analyst, or whatever it is. So really beware of the proliferation of GitHub repos that can be a bit of a vanity metric, right? We all love going to our GitHub repos and feeling really intense because we have a whole bunch of things forked there, and you don't want to do that as much as possible. Back on the selling yourself train, blog posts are really important. By the way, blog posts, they should turn into a README on your GitHub repo. So when somebody checks out your GitHub repo, boom, they should see that blog post. Videos, you can make a video of yourself walking through your code, explaining it, even create a short slide deck or presentation. People are always curious for this kind of content, and especially like if you make that video and then you publish it along with your blog post, like for Towards Data Science or something, and you have a link to that video. People love that, and people love to see other people's projects. You guys probably do. Most people, I certainly do. If I'm looking to break into a new space, seeing what other people have built that's worked for that, I think it's a great idea, a good way to get attention. ML Reddit, this is a really good distribution channel. So once you've done these things, once you have your content, your GitHub, your deployed app, blog post videos, go to ML Reddit and share it. And Hacker News, sort of same thing. The populations of these, the denizens of Reddit are known for being a little contrarian and sometimes, I don't want to use the word nasty, but don't be bothered by it. I mean, a lot of people like they can only criticize your project if they actually looked at it. And so that feedback can help you improve your project, and it can also, chances are you're going to, I don't want to overplay this, you're going to get overall positive responses, I'm sure, but just like, have a bit of a thick skin, especially with this guy, Hacker News. Some pretty negative comments come from there. Anyway, LinkedIn, of course, share your stuff on LinkedIn, and this is where adding connections is really helpful, especially if those connections are hiring managers, just because they're basically subscribed to your advertisements. Every time you put up a LinkedIn status, it's an ad for yourself. So this is a really good thing to include on your LinkedIn, separated into a couple different posts too, things that you learned while building this project. And give people something to follow. It's not a bad call. And same goes for Twitter as well, though a little bit lower leverage than LinkedIn usually for that reason. So that is my walkthrough. Does anybody have, some questions here. Jeremy says, what are some of the distinctions that should exist between a blog post and the README? Is one more story-driven, instructional, descriptive, prescriptive than the other? Yeah, really good question. So this does depend a little bit. I think different people have different styles when it comes to blog posts. Some people like to write their blog posts in a very narrative kind of way. That's my inclination. To be honest, you can basically just put the blog post and make it identical to the README. Like, you don't need to change the two. The README essentially is just like an excuse to get people's eyes on that blog post. And you might include some instructions on how to run the code, just as a line or two before you get into the meat of things. But it definitely can be the same thing. Yeah. Okay, cool. Looks like most stuff. Does anybody have any thoughts or questions here? I can poke a couple of you guys. Jerry, do you have any questions about this stuff? Oh, if you can't talk, I can skip over you. I just want to do a random sampling here just to make sure. Okay, sweet. Joe, all good? All right, sweet. Okay, well, maybe I'll leave things there, and I'll post the video of this later. But yeah, thanks for stopping by. Hopefully that helps a little bit. Feel free to shoot me a message as always if you have follow-up questions down the line. Thanks, everyone. Thanks, guys. Appreciate it.